Welcome back, everyone, to another explainer. I am absolutely thrilled you're joining us today because we are tackling something incredibly fascinating. If you've ever wondered exactly how a robotic process automation system, an RPA, is actually brought to life from the ground up, well, you are in the exact right place. Think about it kind of like constructing a state-of-the-art office building. But instead of bricks and mortar, we're deploying a digital worker entirely from scratch. We're taking these abstract concepts and turning them into a fully functioning, highly secure digital workforce. To demystify this whole life cycle, we're going to follow a clear chronological four-part roadmap: architecting the solution, setting up the infrastructure, testing the automation, and finally, migrating to production. Section 1, architecting the solution. Okay, let's dive into this blueprinting phase of our digital construction project. So, looking at a standard Blue Prism environment, you'll immediately see this clear hub and spoke model. Over on the left side, you've got your development, quality assurance, and production virtual machines. These are essentially the environments where the bots are built, tested, and finally set loose to do their thing. Now, notice how all of these interact directly with that central hub right at the bottom, the RPA server. That server is absolutely the brain of the whole operation. It houses the robot code, it handles the orchestration, keeps all the logs, and enforces security. The VMs are effectively the limbs actually doing the work, but they all report back to the central nervous system, which then reaches out to your target applications like your CRMs or ERPs. But what happens if that central hub encounters a major issue? Well, take a look at this incredibly important disaster recovery setup. We've got two distinct locations represented here. There's Site A, which is our active site, and Site B, which is passive. Site B acts as a complete passive safety net. By utilizing SQL mirroring or replication between the database servers, the system ensures that every single piece of data in Site A is immediately backed up in Site B. So if Site A experiences some sort of catastrophic outage, the operation can just smoothly fail over to Site B. This guarantees our digital workers literally never miss a beat, giving us that high availability that enterprise-grade automations absolutely demand. Moving right along to Section 2, setting up infrastructure. Now we transition from looking at visual blueprints to laying the actual concrete foundation, the hardware and data specs. Think about the different engine sizes you need for different tasks here. The application server up at the top, that's your heavy lifter. Because it hosts the Blue Prism server and potentially the database, it requires a pretty hefty minimum of 32 gigabytes of RAM and a 64-bit processor with 4 vCPUs. But scan down to the runtime resources, these are the black box machines where your everyday digital workers actually execute their tasks. Those only need 16 gigabytes of RAM. So the infrastructure is scaled super efficiently. You're putting the heavy computing power exactly where the orchestration happens, while keeping the execution nodes lean and standardized. Now, infrastructure isn't just about RAM and CPUs. Believe it or not, just like bringing on a new human employee, your digital worker actually needs to go through IT onboarding. They need a single official robot ID with specific privileges to log into systems like SAP or SharePoint. They need their very own email ID to send and receive communications with business users. And they need a desk, or, well, in this case, about 50 gigabytes of shared disk space on a SharePoint or shared drive to store the reference files they're going to be working with every single day. Let's move to and see how this builds chronologically. The installation follows a very strict 5-phase timeline. You can't just flip a switch here. You start with Phase 1, infrastructure planning with your IT department. Then Phase 2 is infrastructure testing, handing over the credentials and validating the setup. Only after that do you configure the development environment, which is then followed by the testing or UAT environments, and finally the production environments. Every single step is a prerequisite for the next, making sure everything is totally stable before a single line of automation code is ever written. Section 3, testing the automation. The foundation is poured, our digital workers are built, so now it's time to put them through their paces. There's a really vital dichotomy in how we actually test these bots. First step, we have on-screen testing. Think of this as basically holding the bot's hand. Users can actively access the robot during the run, control the inputs, and validate the results after every single step. It's highly interactive. Contrast that with black box testing. Here, the bot runs completely unseen. There is absolutely no access to the robot while it's running. Users just control the inputs beforehand and only get to validate the final outputs after completion. It's really the ultimate test to see if the bot can survive in the wild, all on its own. So how long does all this testing actually take? Well, timelines scale dynamically based on process complexity. For a low-complexity process, internal testing and user acceptance testing, or UAT, might only take 1 to 2 days each. But look over at the high-complexity column. A highly complex automation requires up to 5 days of intensive internal technical review, and then another 3 to 5 days of UAT with the business user. It really highlights that a proper RPA deployment absolutely does not cut corners on quality assurance. And that brings us to section 4, migrating to production. This is the final stage of the lifecycle where we carefully package the bot we've built and tested and finally unleash it into the live, real-world environment. Before a bot can move to production, it has to literally pack its bags. In the release manager, developers follow exact procedural steps to bundle everything, the core process, the objects, the credentials, and the work queues, into a single, highly secure package. And notice step 2, it has to carry the exact same name as the process itself to maintain really strict version control. Now, what's really interesting about the slide is the strict governance required to actually move that package. Looking at the Blue Prism migration request form here, notice those specific tabs highlighted in yellow, the process tab and the migration checklist. You can't just email a file and say, hey, go live. Developers are required to meticulously document the schedule, the process information, and submit this formal request to the virtual operations support team for review. Drilling down into that migration checklist, we see it effectively acts as the digital worker's passport. Look at those columns, moving from development to QA, and then moving from QA to production. Before a bot can cross those borders, it requires essential sign-offs, specifically from the service line migration approver. It tracks the package name, the date, and whether it's explicitly approved to move based on the code quality and testing success.
So the crucial point is, how do you actually earn that final approval? Through validation runs. A validation run isn't just turning the bot on once and keeping your fingers crossed. It requires consecutive successful runs of a process on the prior environment. If you're migrating to QA, you must have successful runs in dev. And the absolute gold standard of migration, as noted right here, is achieving 3 consecutive flawless validation runs. Only then is the process deemed stable enough for the big leagues.
We have covered a massive amount of ground today, from the initial architectural blueprints and VM specs, right through to rigorous black box testing and those highly governed migration checklists. Deploying a digital worker isn't just some quick IT project. It is the meticulous construction of a completely new type of workforce. So I want to leave you with this provocative question to ponder. Is your infrastructure and governance truly ready to support a digital workforce at scale? Think about the exact life cycle we just mapped out and ask yourself if your organization respects the rigorous deployment it demands. Thanks so much for joining me on this explainer, and keep learning.